own constraints, working within your own parameters. Number 4, there's barely enough time to train your athletes, much less educate them on why they should be doing what you're asking. So that buy-in factor gets to be really challenging because all you have is an hour with them. You just got to make them do things, and sometimes the why isn't always a capable means of presenting that to them. And number 5, when you search for answers, you're overwhelmed with too much information and an inability to determine its credibility. And that I deal with the same thing today. You know, you read a new article, read a new post, and it's like, is this person really credible? You know, should I believe what they're saying? And then you go to find one answer and you end up with 12, and you're like, great, and then you're just lost. So what I'm going to try and do today, as much as I can, is just prevent relevant information, sift through all the other nonsense and things that really don't apply to you, and just give you the meat of it all, okay? So let's define power, because that's largely what we're going to talk about today. We're going to break it down and understand how everything contributes to it. First, we're going to do a little thinking exercise that I want you to go ahead and do in your own mind right now, okay? We'll take a couple minutes just to do this. And you can think out loud, you can respond to this, but what do you guys think the powerful athlete looks like? Or when you think of, hey man, that guy is powerful, he's explosive, he is an athlete, he's athletic, what comes to your mind? What visual do you have? What does that person look like? What is that person doing? Thoughts? Go ahead and think about it to yourself, because I want you to take what you already envision as being somebody who's powerful, and that's going to help us kind of build on that for the rest of the talk. But maybe just 1 or 2 things. Anybody?
Fluid.
I'm sorry?
Fluid.
Fluidity? Very good. Mechanics probably having a lot to do with that. Just rhythm, just things kind of processing well, right? What else? Posture? Is that you that said that? Or posture? Yeah, absolutely. Because power, we're going to learn about in a little bit, has to be translated or has to be emitted through your body in a certain way. That posture is so significant to make that happen. Maybe one more? Maybe what is their physicality like? What do you picture?
I picture a sprinter.
Picture a sprinter? Yeah, that's definitely what came to my mind. In fact, when I was going to put an image on the slide, I thought of Usain Bolt. I was like, for sure, I'm going to put him on here. So powerful, so explosive, so fluid-like, and obviously great posture as well. So the reason why I'm presenting this, or starting out with a question, is that what we're going to learn with this presentation is that there are so many things that go into making you powerful and to becoming a more powerful athlete and developing that, okay? So we're going to help define what a power athlete actually is. So we're going to look at one athlete who I believe is incredibly powerful, and he's going to kind of be our model for the rest of the talk, okay? Doesn't mean that you have to look like that to be powerful, but in his particular sport, Mr. Dmitry Klokov excelled, and he is just incredibly powerful to the point that we can kind of learn from him. We can kind of reverse engineer him as far as to what made him good. So some of his accolades here, he's retired from weightlifting now, but he's still weightlifting. He was just seen at the Worlds in Houston not too long ago doing a hang pause snatch with, what was it, 440 pounds, something like that? A pause snatch, yeah. So he's still explosive, he's still strong, he's still working with it. Look him up on YouTube. We got several videos of him today, actually, but I'm a huge fan of his. But here's kind of our model. Like I said, we're going to kind of dissect him a little bit. We'll break down some of what makes him powerful, what makes him explosive, and we're going to see that really carries over to a lot of different sports, not just Olympic weightlifting. Sprinting, jumping, a lot of the characteristics are the same, but of course, they may all not look like him. But when I think power athlete, that's kind of what I envision. All right. Simply put, this is important to go over, the physics as basic as we can. The physics can get extremely overwhelming with all the variables, but we're going to be simple today, y'all, all right? It's the mathematical product of force and velocity, okay? It can be measured quantitatively. Power equals force, I'm sorry, that's a typo. Power equals F times V. Power equals force times velocity, all right? Sports definition, the ability to exert a maximal force in as short a time as possible as in accelerating, jumping, throwing, etc., you name it. Everybody's kind of familiar with that, right? It's a combination of force as well as velocity, but it's so important to understand that because from there we can begin to dissect that more and understand what makes force better and what makes velocity better. So this is a great place to start, kind of a foundational definition for us. While strength is the maximal force you can apply against the load, power is proportional to the speed at which you can apply this maximal force. So breaking down a little bit further, again, just the relevant information, here's force. It is another equation in and of itself. It's mass times acceleration, okay? And effort that changes distance and shape of the mass is what force is. It's just whatever is being applied quantitatively to the body, to an apparatus, to a resistance. That's what force is, right? What's another synonym for force that you guys are familiar with? Starts with the S. Strength. Strength and force really are used synonymously here, okay? So don't let this word confuse you too much. At the end of the day, it's just how much force is being applied, all right? How much strength. Velocity, really a lot different. This really deals with time as a main component, right? It's the fluidity of the motion. It's just the rate in which force occurs, and maximizing both of these two things leads to power. We have to understand that it's not just about force, like Dr. Merrow's talked about, and it's not just about velocity. Depending on how you want to use power for success in your sport, we got to maximize both of these things, all right? So another example of kind of a better way to explain it is the heavier the weight, the slower you lift it. So that's more force is necessary. So velocity kind of goes down. Whereas the lighter the weight, the faster you lift it. So what we end up finding here is that there's quite a substantial inverse relationship between the two, okay, in most cases. I can move something a lot faster if there's less force involved, and I can, well, not necessarily. So that's kind of the caveat there is I can still have a ton of force being emitted, and it moves fast because force is necessary to move that velocity. But in regards to what it is that I'm moving and the implement, the resistance, or whatever it is, if that in and of itself doesn't require much force to move through it, then man, I'm gonna breeze through it. I'm gonna do that fast and explosively. Does that make sense? Okay? This is super important because when we talk about training and how we train, we need to train fast and explosively, and we're gonna get to that. Here's a chart that helped me dramatically understand this even more so, because again, I just want to make sure that we're all on the same page in understanding how truly we can assess power and calculate it. Here we got velocity on this axis. We got force on this one. Where do you guys see power as being the greatest? It's about right here. It's a lot closer along the lines of velocity than it is force. So as force really increases to its max capacity, we start really losing out on power. And of course, we lose out on velocity. And that's a key thing to understand. There's a nice balance between the two to maximize them, but power is really kind of somewhere in the middle, but really more towards the velocity end, okay? And this is why I chose an Olympic weightlifter to do a model, because an Olympic weightlifter, when he's snatching, as much as he is that bar moving slow? Not at all. I mean, it's a matter of how quick, if you can't pull that bar fast enough, that weight's just not gonna go anywhere. So at the end of the day, velocity has probably a greater impact on power. We see that from this chart. We see that from this other one too. We'll get back to that one in a sec. Here, it's flipped, so don't let it confuse you. We got force here at the top, velocity here at the bottom, maximal strength effort. So this is regard to training. When you're thinking about training and how it relates to 1RM, we understand 1RM to how much weight you can lift with one repetition. If I want to maximize force, that's really where I should be investing my time and investing my effort, whereas speed, a lot less resistance, but I can move that a lot faster. I think that chart is helpful. When you're talking about a periodized plan, if you're Usain Bolt, if you're a sprinter, speed is your ultimate end goal and that's what you want, then really that should be a priority in the sense that everything builds up to it. Everything starts from a nice foundation of developing force first, because force takes a long time. Force takes a long time to develop in the sense of hypertrophy and strength, and eventually consummating into extreme power and extreme speed. So this is an example of a plan that speed is king and not necessarily power. Whereas if power is at the bottom end, you probably wouldn't venture too far down this line and lose your force. You would keep the force there. So really a lot of it is relative, right? I like this one a lot because it now involves the muscle tissue. Here's force again, there's velocity again. We're able to generate the most force eccentrically when the muscle is lengthening. And when the muscle is shortening, we're able to increase the most velocity, okay? And somewhere in the middle is our length tension relationship principle, which tells us that the muscle is really at its most powerful whenever it is somewhere in the middle, okay? And that's called the length-tension relationship, and this would be the optimal length for explosiveness. But we all know that we go through this whole cycle to generate power in a cyclical motion within our joints. So I'm not trying to point out that any one is any different or any better. It's just interesting to see the relationship between force, velocity, and your muscle. Yes?
That previous slide,
Uh-huh.
so that right there, is that, I guess in layman's terms, saying that we should focus on that degree of strength and progress from there into a more power type programming, then ultimately end up where the athlete's faster, able to produce more force and power. So that's kind of like that.
Yes, correct. And again, this periodized plan. So let's say this is a track meet on January 3rd, right? This is the end. This is where I want to peak, like my one shot. Or this is a Mayweather versus Pacquiao. This is when I'm fighting, right? Here is maybe I just finished my last fight, or I've got a long ways to go. There is a long-term and logical sequential progression that you would take in order to maximize where you're at. So if speed truly is my end goal, and this is everything that matters in my success in my sport, I'm not going to be doing this stuff when I'm about to compete. I'm going to be doing a lot more of this because it's more relative to the timing of my competition. That doesn't mean that you should just totally never do this ever when you're here, or never do this when you're here. Dr. Melrose really stressed that use it or lose it, right? Like if I'm not swinging a bat or running sprints early on, then I can lose that stimulus. So this is just a general guideline of emphasis. That's the word I'll use. You're emphasizing these areas early on and then progressing here at the end of the day, okay? And this can get extremely complicated, right? Because it can change, or maybe this is conference tournament, and now this is NCAA tournament, and maybe I don't even know if I'm going to get here, or maybe I have 4 fights within a year, and that I got to prepare, and then it all depends on the athlete's peaking phase, the sport's peaking phase. So periodization is one area that unfortunately nobody's talking about today in our clinic, but it would be really smart of you to pick up on a book or two about sample periodization plans and how to really maximize athletic performance on a long-term scale. Again, I don't want to get off topic, but I could talk a little bit more about it. But if you have questions more on a long-term basis of developing power, I'd love to talk to you about that. Great question. Okay, so now let's get into it. We understand that both of these things are important for power, okay? Now, what contributes most to power and what contributes most to velocity is good for us to know, because that's what we're doing in the weight room. We're trying to actually break this down. Okay, how can I get more force? Or how can I get more velocity? Let's say we ran through and assessed so-and-so athlete, little Jimmy. And little Jimmy, he's got great velocity, but he's got terrible force, okay? Now we know kind of where to really prioritize our program, or vice versa, or both. Maybe he's decent at both, but not great. Depending on your goal, obviously there's an interplay between these two things. So let's break this down and let's really find out what contributes most, all right? 3 big things. The first one is recruitment of the muscle tissue, okay? In exercise physiology, this is considered motor unit recruitment. It's really the ability of you to recruit all of the muscle fibers, all the motor units within your muscle, or within the muscles that are actually carrying out the action, the movement, okay? So an illustration would be, you've got an army of 10,000 troops and you're about to go to war, and you really only call on 7,000. Or only 7,000 are used to fight this battle for you, instead of all of the motor units, all of the soldiers that, if you will, that you can use to really win this battle. Does that make sense? This is a trainable thing. This is very trainable. We can recruit more of our soldiers just by building their morale, if you will, really practicing, recruiting them through training, through every rep, every set. We can teach the body, hey, we need more of you guys, let's use you, okay? Because typically our bodies are conservative and they want to not do as much work as they need to. So in most cases, if you're untrained, or if you just got back from spring break and you haven't done anything, or Christmas break, your body's going to take the approach of, I really only need to use this much, so I'm not going to give everything right now. So a lot of it, we have to cue our bodies to maximize its potential. A lot of people think when I strength train, I just get more motor units and get more soldiers and more soldiers, but a lot of it at the end of the day is just using what you already have, okay? 2, synchronization of your motor units. So this is a kind of a timing thing within force where a lot of times your motor units don't necessarily fire at the same time, or they don't execute well within a repetition. So this can also be trained with cueing a lot of the right muscle groups. So this muscle and this muscle, if they're both working together to produce this movement, we can get a lot of work done, but they're not. Right now they're not in sync with each other. Things aren't working. So even this term synchronization can apply to all the units within one muscle or several muscles working together in sync to carry out the task, right? So everything kind of connecting the dots and applying force at one given moment. Again, Olympic weightlifting. If you guys aren't familiar with that, simple bar on the ground, you got to cue that everything in your body to pull that bar with maximal force and then accelerate that bar above your head. If my right glute doesn't want to work when I'm doing that and my left glute's doing all the work, I'm missing out on a whole lot of potential for force. I got to get everything kind of firing together, right? And then lastly, the rate at which the firing occurs. So unlike most sports, Olympic weightlifting is just a one-time gig. Although the movement itself involves a lot of tasks, a lot of joint tasks, it's really just one rep versus most other sports involved repetitive repetition, sprinting, basketball, volleyball, you name it. What is our capability of the duration of the contraction as well as the time between each contraction? Can we maintain the force? Does that make sense here? Maintenance of force, rate that the force occurs, all these things play heavily into the overall product of how much force is behind the power component, okay? Velocity, which isn't as sexy sometimes as the force, but man, is it more important? Is it just as important, if not more important? Because if things aren't linked together sequentially, if I'm not using this joint, then I'm really not maximizing the way that force is being distributed, right? And a lot of this comes down to mechanics, comes down to technique, it comes down to execution, communication between your body and your brain. A lot of that has to do with accuracy, technique, those kind of words that you hear to define biomechanics, right? There's really two categories in which this occurs though, because your joints can be communicated kinetically all at one time or sequentially. So a lot of athletes that I deal with who've never really lifted weights in high school and we're trying to get them, they're already doing a lot of sequential movements in their sport, but they've never really ever had to do just cueing everything like in a deadlift sense for one repetition, because in their sport relies more heavily on sequencing things and not so much of cueing everything at one time mechanically. So this really is a lot harder to teach than some of this stuff to some of them, because it doesn't come as natural. So I have to spend a lot of time cueing just their brain to understand getting everything communicating at the same time, which really kind of relates to synchronization. But at the end of the day, if that communication is there, things are just going to travel much faster, and we're not going to have this issue as much, okay? I don't know if y'all have heard this term before, but energy leakage. It sounds kind of gross sometimes when you're using that word a lot because you're like thinking about power. But at the end of the day, power and force, because force is really the birthplace of everything. This is where everything generates from. If the velocity is not there kinematically, this can actually dissipate throughout the movement, and you can lose a lot of your potential for power because force is going away. So posture, if that's not right, things are going to leak out. If all your muscles aren't balanced or symmetrical or even asymmetrical in the way that makes you successful for your sport, you're going to really miss out on a lot of the force potential that you had to begin with, okay? So y'all see the interplay here between force and velocity? Here's just some terms that I think just help us understand power in a better sense, more detailed terms. Power, really force is the priority in the sense that you're cueing everything to just generate force through velocity, whereas speed, on the other hand, force is not the priority. It's more about cyclical motion, maintaining fluidity, driving through, good mechanics. We see that with our world-class sprinters. It looks effortless to them when they're running world record sprints. Some other terms that help us really train power and velocity, we hear work, volume, distance, duration. We're going to come by these terms again, but at the end of the day, if we don't understand sets, reps, intensity, volume, and how all that can be calculated to contribute more towards velocity or more towards force, then we're really missing out on how to accurately use weight training to make us more successful, to make us more powerful. So if you're unfamiliar with a lot of these terms or any of these terms that you see later on, make sure you raise your hand, shout out, because I want to make sure that when we're actually getting into the nuts and bolts of it all and putting it all together, that you guys know how to use it from a programming sense. Okay. Why is power important? It's necessary for a lot of things. Okay. I don't think I have to sell you guys on power and its importance. It's really the one area that we feel like sport is most successful with. When you're displacing something, whether it's strongman, powerlifting, weightlifting, if you're going for height, if that's your priority, if it's speed, if it's distance, power really has a different role in all of these things, but at the end of the day, it's an essential component for success, okay? And it's hard to talk about. I mean, I'm up here prioritizing one element of sports success, but you guys know that there's so many things that go into being successful at sport that it gives you a headache. If the athlete doesn't have the right mentality, if they didn't sleep the night before, nutrition, there's so many other things that go into sports success, of course, and we don't have time to cover all that in one lecture. So it's smart of you guys to get into everything from an interdisciplinary standpoint of all the variables of sports success, but without a doubt, this is a huge part of it, okay? And the better we can maximize this, the better chance that we have to be successful. It doesn't mean it's going to guarantee you success. I have incredibly powerful athletes that sometimes when they get to the dish, they get to the plate to swing and do something for the team, it's just not there. It just doesn't happen. So, this helps us, but it doesn't guarantee success, all right? Of course, I just feel like that needs to be said. But it doesn't mean we shouldn't strive for it. Let's maximize power. So one last kind of illustration to help put it together in a way that I think is also helpful. In this illustration, we have a row crew of 8, and this is the Canadian rowing team. And what allows them to be successful and to go 2,000 meters in 5.5 minutes or so is the execution really of both force and velocity. So in order for them to be successful, they have to be in sync with each other. They have to be synchronized. So that's kind of relating to our motor units a little bit. Acceleration is absolutely important, where they're driving through as explosively and as fast as possible. If they're not giving their all in that sense and accelerating, then they're not going to be as successful as they'd like to be. And strength is a huge part of success in rowing, but because it's 2,000 meters in 5.5 minutes, which is probably one of the most brutal things in all of sports to accomplish, endurance is definitely an issue, right? Power, endurance, just be able to maintain that high amount of strength and acceleration for a long period of time. And then velocity kind of relates to the entire execution of the crew and the way that they're all in sync and the way that they drive, the position of the paddle, all that takes what's already is being produced with force, which at a very high level, and it's distributing it well to achieve success in a short amount of time. Power, how do you get it? So let's get into this nuts and bolts a little bit. I have 8 variables that I put together for sports success. And this isn't just off the top of my head. I've read a lot of books that really point to these 8 things. And time again, I come across, when I want to develop power, either one of these things is hindering overall power production or one of these things is being overstressed, okay? We have to understand how all 8 of these variables, which I'm sure there's more, you can come up with different subcategories for these things and maybe add a 9th or a 10th, but for the sake of, conceptualizing what we're trying to do today, let's stick with these 8 and let's explore them and let's explore their role, okay? But like I've said, we can emphasize one thing too much and totally ignore another. We can and do the opposite. We have to understand an interplay between all of these 8 variables, okay? First, I already had this mentioned before. I have a really awesome video to show you guys. We're going to have a cloak-off video for every variable, so you guys prepare yourself. This is a 374-pound snatch.
Подход посвящается моей жене.
You can never understand what he's saying.
Пускай расстались ненадолго, но все равно немного жаль. Хорошая моя, я по тебе сейчас скучаю, и треплет душу мне любви, необычайная печаль. Да! Атака, бляха!
So in the power position, he recited an entire Russian poem. What does that tell you guys? Incredible core strength to not allow any energy leakage whatsoever in just the initial pull and the situation that he's in, and still be able to come out of that concentrically with a lot of power and force, all right? I saw this video and I just immediately was like, we got to do this in the weight room here. Like we have a motto, it's called the Islander Way. Islanders are prepared to achieve success through integrity and respect, devotion to team above self, and loyalty to the island universe. I'm gonna have my athletes start, when we start doing our isometric pulls, you're gonna have to recite that, because not only you're cueing your diaphragm when you're spitting out words because you're trying to do as fast as you can, things stay intact. I love that, because it reinforces a really important part of power production, which is the ability to just stay locked in, the ability to keep things intact and tight. I could spend an entire presentation on posture alone, posture integrity. In fact, I did 2 years ago at the College Station, Texas State Clinic. All I did was talk about posture, and you guys can find that on YouTube. And I still rewatch that over again to remind myself of how important posture is within sport performance, all right? So on all these 8 variables, I'm gonna give you guys 4 things, okay? I'll give you kind of the role that it plays, how to really assess it. I'll give you how it's enhanced, and then considerations for it, okay? So we'll blow through these. Hopefully I don't spend too much time on one in particular, but this one, guys, you know, maybe I'm a little biased, but I really think this is probably the most important one. I mean, yes, you can have explosive strength and explosive power concentrically, which absolutely contributes to power, but you have to have a foundation in which it's built. So when I think about posture, I think about building a house and just laying that foundation and just having a sturdy structure in which to perform, okay? Read this out. It's to prevent energy leakage. That's the role, and it's to protect your spine. It's to protect everything and just keep everything from being injured or keeping things optimal, okay? To assess it, ton of different ways to assess posture, and really visually is a great way to do it. But I use that word integrity because what we know about integrity from a character sense is, you know, not telling lies when under pressure, doing the right thing when no one's looking, okay? Integrity only really shows up whenever there's stress involved and there's pressure involved, okay? I may not tell a lie until I'm under a whole lot of stress and there's some extreme ramifications, and then I might tell a lie and my integrity is compromised, okay? In the same sense, we gotta train posture the same way. It's one thing to hold the plank all day long and say that you have great core strength, but then try deadlifting twice your body weight, or try cleaning, snatching, jerking, sprinting as fast as you can for 100 meters. Then you'll be surprised about how truly strong your core is. So yes, you can assess it in a low threshold sense, but to really understand how good somebody's posture is from an integrity standpoint, let's load them up, let's put some pressure on there and reassess. Does that make sense? Strength lifts will help you assess it. The ability to sprint and jump, translate force, landing drills, cutting drills, biomechanical analysis. Jumping is an interesting one. Posture integrity really plays a role in jumping between the power production phase and the power execution, or the power release phase. If your posture is not good, if your core is not strong, you're not going to translate that force as well, okay? It's like a conduction deal where you have a medium in your core and it's having to translate all this power through it in order to carry it out. We can assess this by actually looking at somebody's counter movement jump and seeing how high they get, and then looking at just their hold counter movement or non-counter movement jump, where they're just here, and then looking at the difference between the two and seeing who can really jump based on the counter movement and the non-counter movement. Or we can even look at, with a force plate, just the ability to load up into the force plate how much force is produced there, and then how much force is actually produced concentrically, and then taking the difference between the two, all right? The successful athlete can use all of their force and transmit it really well. How do we enhance it? I can't stress this enough. Education. Not only you being educated to cue optimal posture in a deadlift, in a squat, in a clean, no matter what, in a sprint, in a jump, but for the athletes to also cue themselves. The athlete needs to be educated on what optimal posture is for whatever movement that they're doing. And I love this quote. I used it in my last presentation on the topic that Dr. Spino gave. There's an optimal way to do everything, okay? Whether you're bending over to pick something up off the ground, throwing a fastball, there's really an optimal way from a positional standpoint to do it. What is it? do we care enough to know the most optimal way to carry out a task? Let that soak in for a little bit. If you're okay with having little Jimmy just do his deadlift and his back is rounded, he's not cueing the right muscles, the glutes aren't engaged, it's a lot of lumbar flexion, bars over his toes, so his center of gravity's off, and he doesn't amount of weight that you want, and you just let it happen, you tolerate it. And Dr. Melrose would say you're perpetuating just bad technique over a long period of time. You're not caring enough about what's the best way to do it. How can little Jimmy do this without expending more energy than he needs to? What is a way that I can just maximize efficiency with as little stress, unnecessary stress as I need to? We do it the same with our finances. We do it the same with life. We're trying to not waste time. If I'm driving to Starbucks, I'm going to avoid traffic and I'm going to go around the ways that I know will get me in the shortest amount of time without me getting pissed off and yelling at somebody. Let's apply that to our mechanics. Let's apply that, hey, what's the best way to carry out this task and not waste energy? You guys with me on that? Because, again, building off what Dr. Melrose said, your athletes may not be hurt right now, but you're stressing something that over time, later down the road, can cause some serious problems. And by the time they get to us, Division I collegiate level, we got some pretty beat up people. And a lot of it is because they did a lot of bad reps instead of a lot of good reps. How can we make a good rep better? How can we make a bad rep good? You guys with me? So don't be afraid to start with just the simple progressions of body weight, using a stick, low threshold. Let them learn the position first, then you start taxing them. All right? I'm all about stressing somebody else. That's my job. I put stress on people. I make them do stuff that they don't think that they can do. That's what I do for a living. But I still appreciate quality in the sense that that's a priority initially. Because if I have an athlete for 4 years, which I hopefully do, if they have a long career and they're successful here, it's an investment. I'm planting a tree. I'm planting a tree that should hopefully grow up this way. So I'm going to set up some stakes around it to get it going upright. And I'll start freshmen off with a lot of just basics, knowing that by the time they're seniors, or even as freshmen, they're going to be really successful, okay? So really think about quality. This has a lot to do, integrity, quality, all that kind of is wrapped up in the same umbrella. Strength. Really the moneymaker, or the one that really gets our attention when it comes to power development. I have another video, of course. Klokov, he snatched all that weight. He's got all these world championships. This was part of what made him successful, training for strength. Okay, this is after he was already retired, still lifting heavy weights. The point being, strength has an incredible role in power production, especially in the realm of force, and really primarily in the realm of force, because I told you those terms are really synonymous, strength and force. It's the birthplace of power. Really, there is no rate of force without force to begin with, so it has a huge role in power development. If maximized, it can greatly contribute, all that stuff, but disclaimer, it isn't everything, okay? Just because you can deadlift as much as Klokov can does not mean you can snatch as much as Klokov can, okay? At the end of the day, velocity, mechanics, posture, all that stuff plays a huge role. So how can we use strength in a way that it's not the end product, but in a way that it can be leading to explosiveness? So we're thinking, if I'm doing a strength exercise, I'm thinking of the next step, which is how can this be eventually explosive in some way, shape, or form, okay? But at the end of the day, we still need to start somewhere, and building a nice strength base is important. It really challenges our postural integrity without being too dynamic. We can kind of cue things slowly with a lot of force, a lot of control, and then we can start doing things explosively without any energy leaks. So we're patching up the leaks here with strength training. A lot of ways to assess it. One of our favorite exercises here from unilateral approach is a modified single leg squat or Bulgarian split squat, where you put a leg behind and we actually load athletes up on the barbell. I had a shortstop 3 years ago do 405 one time. Touch knee, and he squats like 565, or at the time he did. Now he's squatting 600 plus. But I'm interested also in unilateral strength and not just bilateral strength, because that really tells me a lot about, again, energy leakage. Yes, there's no energy leaks like this, but are there energy leaks like this when I'm jumping, when I'm landing this way? So again, it kind of comes back to posture. What are we doing for the stabilizer muscles, for the other muscles that when I'm in a different position, things change when you're in a different position. Now you're dealing with a whole nother situation. And Dr. Melrose said, you know, I laughed at this. He said, Coach, I'm not sore anymore. You know, I'm trying everything, I'm not sore. Well, try something unilateral. I guarantee you won't be able to walk for a couple days after that. Do some heavy modified single leg squats. Your butt will be sore for weeks, okay? And our athletes, it's a love-hate relationship, but we see an immediate correlation. We do a lot of research here. We see a direct correlation between modified single leg strength and throwing velocity in our pitchers. I mean, the results prove its worth. Of course, you got to be smart with the way you execute things. Can't go on without saying, of course, you assess strength with the 1RM. You just got to be smart in the way that you do that and make sure the athlete has the postural integrity first, right, before they're just loading them up and just seeing how much they can do. Sometimes it's more appropriate to do a 3RM or a 5RM because the more force you add on, the more integrity is challenged and then injuries can occur. So just be smart with that. Enhancement, the way that we can increase strength, you guys have seen a lot of this before. Volume is king. Lots of sets, lots of reps in the sense of, 6, 7 sets of 5. Don't be afraid to just really go a lighter percentage of 75 to 85 and just do a lot more sets. You're going to get a lot of strength that way. All right, but still at the end of the day, it's within a 1 to 6 repetition per set. Overall timing, it's really not that long. You're not under stress for a whole long time because the force is so great. You can only handle it for so long. High intensity and typically full range of motion. So we're gonna go to some power type stuff in a little bit, and with the power stuff, it's not as full range of motion as much because what the focus is here is generating strength within the entire joint range of motion, okay? We don't want to have any excuses for a joint not being strong at this range of motion or this one. Let's go ahead and strength train throughout the whole process. Slow, controlled, driving through the full range of motion. Because this inevitably still will impact a quick range of motion movement, but we can really challenge the muscles and the motor units to stabilize a lot more through a full range, okay? So this, you could argue, well, you don't have to go full range to get strength. That's true, but my philosophy is when strength training, let's go ahead and maximize range of motion, okay? Considerations, strength to mass ratio. How strong you are is relative to basically how much you weigh. That's really how a lot of that's determined. So the reason why that's important, because if you're assessing somebody and you want to know if strength is a deficit for them, like are they strong enough? And so you do a 1RM for your whole team and you find out 2 guys are both squatting 200 pounds, one weighs 200 pounds, and the other weighs 100 pounds. Okay, one guy's squatting twice his body weight, one guy's barely squatting his own body weight. Obviously, there's a deficiency there or discrepancy there already. It's just obvious that this person probably should be able to squat more than their body weight. And a lot of what we see here at A&M Corpus is for males, 1.5 to 2.5 times tends to lead to greater success and less risk of injury across the board for our male athletes. Whereas female athletes, 0.75 to 1 times your body weight to as high as 1.75, we see that. Anything beyond that, really it's like, okay, you're probably strong enough, all right? It's probably not an area that you need to be hammering away at. But we do know that there is kind of a optimal amount of strength related to your body weight that's important to key in on. So take data of your own teams and your own athletes and determine, hey, Noah Lisk over at Carroll, he's squatting 400 pounds or whatever, and he's one of the best running backs in the state. What is he doing? Or no, what is his strength to body mass ratio, and how can that maybe be equated as a goal for the rest of the athletes on that team? Does that make sense? So a lot of times, just take what's already being seen as successful with some of your athletes, look at their body weight ratios within their sport, and that'll help you give a good standard or a good goal for your other athletes. How strong is too strong? People get carried away with strength all the time. It's not the most important thing on the planet. If you're a power lifter, yes, but don't get too carried away with it. You could actually hinder your ability to produce force. So when you see this FD, that means force development, and this is rate of force. So velocity versus force. This is the one non-Klokov video I've got for you. So the third one, limb mechanics. Now we're really focusing on velocity now. So this video is like 3 minutes long. We're not going to watch all of it, but it's shown at, or 2 minutes long. It's reduced to 1 to 50-second slow motion. But what you'll see is just absolutely pristine, perfect technique and his ability to translate that force to where kinematics is the reason why he's able to pull this weight the way he is. If it was any more forward, his center of gravity would be off. If the timing of his extension in his joints was any different than what it is, if he's extending his hips too soon or his knees too soon, he wouldn't be able to pull that weight. Everything is timed sequentially and perfectly with the shrug and the pull and then the dropping under on the catch. He's even going to hit his little throw that he's got here because he's so close to the bar. Everything is channeled so perfectly that there's just no way that velocity could be an issue because he's maxed that part of it out. His mechanics are on point. Okay, you can look at the same with Usain Bolt and the way he sprints. Things are just so smooth and mechanical and perfect. And we need to understand how important this is with regard to power production. Because you can have all the force in the world, but if your technique sucks and you have no mechanics, you're not going to be very successful, okay? So I'm not going to spend much time on this one. Technical execution, proper sequencing. It's really not my place right now in this presentation to stress the best way to maximize all these things, right? There's books on each one of these variables that we're going over. My goal in this presentation is just to show you how important each thing is. You guys with me on that? So if I leave you hanging on some of this, I apologize because I just try to do 2 slides for each variable. But come ask me, hey, coach, probably the one area out of these 8 that I'm least familiar with is mechanics. Can you point me in the right direction to learn more about that? I can do that, okay? So my goal is to talk about the importance of each and maybe how to train them a little bit to identify them, but I may not be able to tell you exactly how to have the best pro agility or things like that in this amount of time, but we can have that conversation after. Sequencing, timing, consistent accuracy, the ability to turn your legs over perfectly in a sprint rather than just to the 10 meters and then that's it. How consistent are we with our accuracy in sport? Block jump in volleyball, sliding over perfectly, timing my arms, getting a nice block, landing, and then doing another one immediately after, or an approach in volleyball, or you name it. A lot of sport skills, sport actions require consistent accuracy to be successful, and that's where this comes in. You can assess it by taking videos, having the knowledge and wherewithal to actually diagnose biomechanical issues, and then having a conversation with that athlete about it, showing them a video of, hey, this is the way you're squatting right now. This is how you should be squatting, okay? Or this is how you're throwing right now. This is how you should be throwing. Video analysis is really helpful with that. Or if you're a really good coach and you've had years of experience coaching mechanics, you can just cue them on the spot. Hey, tighten your back a little bit, or pull the bar closer. Don't let it go so far away from you, or whatever it may be. You're going to gain experience with this to the point that you know what to tell the athlete, you know what they need. One cue for 20 athletes typically is not the way to go, okay? You can remind them of some things, but walk around your weight room, find out what's mechanically wrong with somebody and address that and move on. Go to the next athlete, fix something that they need. But at the end of the day, you need to be educated to the point where you know what's wrong and what to fix, right? The way we can enhance it, like I already gave that, good coaching, good teaching, understanding joint angles, understanding a basic amount of physics and knowing really the optimal way to use our bodies. High volume, low to moderate intensity. I mean, the coaches here, Coach LeDuc and his partner brought some equipment that's really used as a training tool. Those are lighter bars that would be great for you guys to invest in. Using a dowel or just a light bar like that allows you to just get repetitions on repetitions, just to practice technique. Imagine the first time you ever learned how to shoot a jump shot or swing a bat or throw a ball. It took tons, thousands of repetitions for you to get it right and optimally. And we need to be okay with that. We need to be okay with, hey, it may take little Jimmy a long time to really get this down, but I'm okay with that. He needs a lot of repetitions with minimal stress. Let's just build that mechanical foundation first. I really am a believer in demonstrating technique yourself as well as teaching it. Athletes most of the time, especially in this generation, are visual learners. So if you yourself aren't going to demonstrate it well, have an intern who does it with pristine mechanics and let him demonstrate it. Or pick an athlete who's like, oh, Kalen's got it right. Kalen, you come over here. Show everybody what you just did. Everybody watch. Everybody watch Kalen. Kalen, do it again. Okay, and then you break it down. Sometimes it's better than even yourself, because then the athlete sees, hey, this athlete figured it out. They got it. Now they're being put on kind of a pedestal, and I want to be that. I want to be recognized for my mechanics. Make this a priority in your weight training program. This is a really big part of what you're doing with your power lifts. And this isn't just weight room stuff. This is on the field. This is the way you jump, all that, right? It all comes into the same. We're not going to watch all this. I'll breeze through it a little bit. So here's Klokoff doing a power snatch progression. Power snatch prioritizes the pull more than it does the catch. So what he's focusing on here is just how explosively he can pull it from the ground, because now we're getting into explosive power, probably our sexiest element of power production, and one of the most important. He's adding weight as time goes on, but his priority in this specific context is speed, is moving concentrically as explosively as possible. So this relates to, in our force parameter, this relates to synchronization of firing, motor unit recruitment, and rate of firing, how fast he's recruiting those motor units. So explosion, explosiveness. Hopefully you coaches use that term. Hey, be explosive one time. Stop being so slow. Be explosive. Drive through the weight. There are a lot of coaches, especially in this room, talking to Coach Leduc last night. He believes that really everything should be explosive. Why come out of a squat slowly? You're training to be explosive. Come out of a squat with some speed, some tenacity, some explosion, some aggression. I can't tell you, probably the most frustrating things that I deal with on a daily basis are track athletes or my other athletes just not being explosive with weights. It's like you're trying to get this the strength stuff to translate to your power stuff on the field, or baseball players. Be explosive, one time. And maybe it's just a lack of confidence with the movement, that their postural integrity is not there. They don't feel like doing it fast yet. But guys, if you've got the posture down, you've got the mechanics down, that athlete needs to be moving that bar fast, or that athlete needs to be driving through it, assuming that it's part of your program. Okay? There's just no questions about it. If you're doing 60% on squat and you're just applying only the force that you need, you're not getting anything out of it. You are completely wasting your time. Apply more force than what you need, right? Because that's what we do with our bodies in sport. I'm not just going to do as much force as I need to run to first base, if I can get there in time. You may not have the answer to that, so you're going to apply as much force as possible with your own body weight to drive through that. Athletes need to learn to do that with lighter resistances and other situations in the weight room and everywhere else. Explosiveness, explosiveness, explosiveness. It's a trainable thing, and it absolutely correlates to power development. You can assess it in a lot of different ways: how high they jump, how far they jump, Olympic lifts, force plate, a lot of stuff you guys probably don't have access to. But hey, do a vertical jump assessment, do a broad jump assessment. There's a lot of things that play into vertical jumping and broad jumping, but really it does tell you if they're getting more explosive or not, because what do you do when you broad jump? You are driving through your hips as explosively as possible, and that could be a good tell as far as the athletes who are doing that or not. Weightlifting, jumps, med ball throws, it's okay that this kind of stuff is lighter. It's supposed to be, because velocity is a priority, but the beauty of weightlifting allows us to maximize velocity with a pretty high amount of weight as well. So this is more, if we went back to our force velocity curve, this can kind of go both ways. It can be more velocity with a higher amount of force, or more velocity with a less amount of force, but kind of depends on the timing of the year, the program, but at the end of the day, it's velocity. Okay, velocity is a priority with explosive power. Okay, so if they're not doing it as fast as you'd like, or things are breaking down, take some weight away. That's fine. If their snatch looks terrible, clean and jerk looks bad, take some weight away and just focus on velocity, and don't let that slip away, because that is such a huge element of power production. Low duration, typically it's fast. I had a note on this slide describing the difference between a power lifter and an Olympic weightlifter, both lifting close to the same amount of weight, but the Olympic weightlifter pulled it a greater distance, I think it was a clean and jerk or a snatch versus a deadlift. So it's a greater distance in a shorter amount of time. Okay? It's amazing. It's like you have your power lifter who's only deadlifting this high off the ground, and it took him 4 seconds or 2 seconds to do it. And you have an Olympic weightlifter who lifted close to the same amount of weight, this high off the ground, greater length, greater distance in a shorter amount of time. What's more impressive? And I'm not bashing powerlifting or deadlifting, but ultimately just the ability to move that bar is a true testament to what we're working on here. It's very technical typically. Sometimes it doesn't have to be. Jumping guys, jumping can be pretty technical. Take time to learn how to teach an athlete to jump better. The eccentric movement, the counter movement, the drive, how to use their arms. There's a lot of people in this world that don't know how to jump very well, okay? So although that doesn't seem very technical, it can be. But it's maximizing the technicality as well as driving through it with high velocity. Elastic power. This is kind of like explosive power, but now we're working on the ability to re-accelerate, to drive through elastically, explosively, and to repeatedly perform a power type movement. So what word comes to your mind when you think about this exercise or this type of training? Starts with a P. Plyometric. The goal with the plyometric, to really say something is a plyometric, is to do it fast. It's not only explosive, but explosive between repetitions. How fast can you recover from the last one and do another one again? Which sports is all about that. Okay, to be successful in your sport is to rebound really high several times if you didn't get the rebound in the first time or whatever. I'm not telling you guys to go and have your athletes do this, okay? All right, there's obviously a substantial degree of postural integrity. I mean, we're reverse engineering him, but we got to be careful when we reverse engineer somebody who's a freak of nature, what got them there, okay? So don't take your 90-pound cross-country runners and put a bar on their back and have them jump across a football field, okay? I'm not telling you to do that. But the example is the same. He's got some force on him, but the priority is rebounding, if you will, if I could use that term, kind of driving in and out of a movement, in and out of a position. Pogo jumps, tuck jumps, rapid fire squat jumps, even doing successive split jerk movements or cleans, assuming that the technique is there, rapid fire. How can you use the elasticity components of your muscles in a productive way? So if you guys remember your ex-phys, stretch shortening cycle is the physiological principle that we're cueing here, which is the ability to contain force and re-release it. It's hard to talk about elasticity and stiffness without bringing posture into the picture, because both of these really have a lot in common. Stiffness is the ability to contain force and redistribute it. If your posture is not very good, then you're not going to be very elastic as well. So both of those things really play together in a lot of ways. You know, and I can't help but think of a gymnast, okay? A gymnast, when they're tumbling down a mat, just the ability to tumble in that way, things are so rigid, things are so stiff that they can stick that landing. Right? You have hundreds and hundreds of pounds of force, of gravitational potential energy and their body weight just slamming down, and they stick it. That ability comes from postural integrity in the sense of your muscles can just absorb a ton of force, like dropping into a squat. Can you do that well and keep everything intact? So that really has a lot to play in to elasticity and to stiffness and redistributing that force again. Does that make sense? So those are kind of two different physiological products, if you will, whereas stiffness, if you look it up in the journals, and elasticity, those two things really, kind of mean the same, but they have everything to do with the ability to absorb force and then spit it out again, decelerating, cutting. The running back who can just cut and drive, man, they are just elastic through that muscle tissue where they're not leaking any energy. Everything is just like from one thing to the next, elastic. And you can really challenge that by doing repeated jumps and cuts. You'll really determine how truly strong somebody's core is or posture is in that particular direction. The way you enhance it, plyometrics, depth jumps are one of the most popular plyometric exercises out there. It's just really a one-time gig of I'm starting in a higher position, I step off, and I pop onto the next box. My ability to pop on is directly related to my stiffness in the joints that are absorbing that force. If I have terrible deceleration and eccentric strength, then I'm just going to crumble when I step off that box, or I'm barely going to jump half the box that I just jumped off of. But if I have great stiffness properties and great postural means, then it doesn't matter how high the box is, I can pop right off and hit another jump about the same height, okay? I read an article about a high school strength conditioning program that uses depth drops to really just assess an athlete's ability to just absorb force to begin with. So before you would enter into a plyometric program, just kind of make sure that they can at least contain the force first before you have them redistributed. So stepping off a box, sticking it. I love to just set an agility ladder out and just go single leg and stick, single leg stick on every single rung of the ladder. So I'm just trying to see if can they absorb the force unilaterally, efficiently through their core, and then once that is accomplished for 2 weeks, then we'll start doing pogos, single leg down the line with hurdles, with greater distance, greater height. But first, I want to make sure that they can absorb the force. You guys with me on that? Okay, most athletes already can because they're successful in their sport, but a lot of times your least successful, most injury-prone athletes just can't decelerate well. So work on that part of stiffness before you are quick to jump to the explosive nature of it. Does that make sense? This can kind of be a complicated subject because it deals with a few things of absorbing force and redistributing it, but understand the prerequisites beforehand, and that will make you successful. It's very taxing on the nervous system, especially if it's rapid fire. You typically need a good amount of rest in between. So make sure the surface too is not concrete or really a hard basketball court. That's going to just tear up the soft tissues in the legs. Shin splints can be a problem because there's a lot of force being driven into those muscles and soft tissues. So just be smart with it. And then one other thing, I read this in an article the other day. It's a great piece of advice. When you're doing plyometrics and you're doing elastic training, try and stick to 2 or 3 drills and do those really, really well, instead of just coming out and doing 8 drills and not spending much time on each one. Key in on 1, 2, or 3 really good plyometric drills, work through those, and then move on from there. Build a nice foundation, which is kind of the theme of this lecture, is just start with the foundation, especially if you guys are dealing with high school athletes or middle-aged people. Some of you personal trainers in here. Okay, got a couple more left. I love this one. How in the world does mobility play into power? We'll look into it. So here's the same guy that we just saw crushing deadlifts, crushing snatches, and it's amazing to see how flexible he is. It's unbelievable. His posterior chain, hamstrings, everything is it just allows force to just transmit so well. And this is a warm-up routine that he does. They just took this the other day at the Worlds, or maybe this was a year before, but he goes through this routine every time. He's preparing his muscles beforehand. Flexibility, coming out of this chair, if you guys were to go straight to the weight room and just start doing some cleans, you probably might not be ready for it. It's a matter of kind of loosening up your tissues, getting everything ready. But also, on a long-term approach, if somebody has no flexibility and they can't cut because they just can't even open up and change that direction, they probably need to be some sort of program that increases their mobility in that particular range, okay? Now, have y'all seen enough? Are y'all impressed yet? Like if you saw this guy at the mall, you'd probably be like, man, that guy probably can't even touch his toes, Yeah, right. Welcome to the world of Olympic weightlifting when power is king, and to be successful in Olympic weightlifting is to have range of motion, to allow that power to work, okay? So here's the role. It's leverage, guys. At the end of the day, it's not rocket science. The more leverage you have within a joint, typically the greater ability that power can be produced, right? It's allowing a movement to finish through the joint instead of just getting stuck. Like if you're boxing, you're always told, hey, follow through on your punch, really allow everything to drive through instead of just here. That's not going to hurt somebody as much if I'm just kind of stopping short. Our body has a natural mechanism of protecting itself called the stretch reflex. I didn't put that on here. The stretch reflex when it detects that a muscle is going beyond its range of motion that is comfortable with, it causes an action that actually counteracts the concentric portion of that movement and restricts power production. Sometimes that's when muscle strains can occur, when you're not flexible, your joint doesn't have good range of motion, and then you're implementing maximal power in a long range of motion, like striding out in a 100-meter sprint, and your hamstrings they're not used to that. They're not used to being stretched under stress. Then that's when you can have an issue. Your hamstrings go. That's why you do a lot of the Nordic hamstring curls, glute ham raises, because you're stretching your hamstrings, but with a lot of stress, that prepares you for those longer distance runs from striding out, okay? You'll have a lot less hamstring issues if you're paying attention to the mobility part of it all, okay? I don't know how much more I have to preach to you on the importance of mobility, but sometimes this is the missing link in the athlete that you feel like should be successful but isn't, or an athlete that shouldn't be injury prone but is. A lot of times you got to double check this. Hey, what's their range of motion like? Are they missing it in this area or in this area? We do our own little screen here called the PRE. We call it the Postural Readiness Evaluation. It's about a 7 test screen that takes about 5 to 10 minutes. It's just a series of global movement patterns like a toe touch, a lunge variation, an overhead squat. And based on all that, we have a qualitative means of assessing range of motion in a global sense. So an overhead squat, that's a global movement pattern. If somebody can't do that really well, maybe it's shoulder, maybe it's hip. I'm not really sure, but I do know that that is insufficient for what I want. So at that point, I've referred them to a specialist like the athletic trainer or somebody that's a lot smarter than me with diagnosing local area issues, and then that's when we can actually establish that something's wrong. All right, so when you're assessing somebody, assess them globally first. It's like, man, that guy can't even get in a four-point stance, or that guy can't even touch his toes. You know, if it's relative to the sport and they're not able to do it, identify that and find out what the problem is. It's also really important to say that flexibility is sport specific. All right, John Jordan, famous basketball player here. He's 1,500 points and 1,000 assists and 1,000 rebounds, something crazy like that. One of my favorite athletes. I worked with him for 4 years. He had a 50-inch running vertical. He was 5'11", and he could dunk just effortlessly. We'd pull out the Vertec. You guys see that Vertec over there? It measures vertical. We'd crank it all the way to the top. He's my height, in fact, a little shorter, and he would touch 142 inches on it, which is like maxed out on the Vertec almost. It's 144 inches. It was unbelievable. I mean, I should have just showed you guys videos. Well, the thing about John Jordan is he had great posterior chain range of motion. He'd touch his toes, no problem. But you get him to do one of these where he's just putting his leg up on the desk and like this, it's like here. He can't, you know, we all laugh like, John, man, you can't even like touch your knee to the desk, or it's just, and he's just in pain, he's grimacing. Well, what we're learning in the latest research is, I don't know if I put this on here, stiffness and compliance in certain joints can actually be inversely related. So if I'm really stiff and I could absorb force, like when I'm cutting like John Jordan, and he could just change directions and fly and all that stuff, his hips might actually become tight or restricted because of that in some areas, because it allows him to absorb force better. So there's a lot more research to come out in this area, and it's hard for me to give you guys a hard answer about how true this is depending on the joints, but basically my point in being is that sometimes an inflexible joint is not always a bad thing, okay? Just because you can't do every super crazy, you know, contortionist, yoga move, you know, whatever, doesn't make you a bad athlete. We're learning that, you know, with all the data we're collecting, we're seeing, hey, basketball players tend to be tight here, but really limber here. Our volleyball players are tight here, limber here. A lot of it is specific to the sport, okay? So don't just go crazy with saying, oh, mobility, and then everybody's gonna do yoga and we're, you know, work through it. Hey, man, you can't even do this until you can do this. It's hard to say what exactly mobility, the importance of it per joint is, but it's still, we can tend to see how, like with the hamstring example, it is important in some contexts. Couple more here. This is kind of a simple video. Here's Klokov doing a 240 kilo squat for 10. The one point I'll make here is, you know, he squats a lot, he's obviously really strong, but it's work capacity that also allows for power to be successful, okay? So just because you can do something really powerfully one time does not make you successful in your sport. How well can we repeat that power and allow that power to endure? And a lot of times it has to do with making the athlete tired, making fatigue a process. Because I guarantee you, in the NFL, in the fourth quarter, between the first quarter and the fourth quarter, you should probably still have just as much power at the end of the fourth quarter and 2 minutes left than you should have in the first 2 minutes of the game, right? So there's a lot of people out there that say, oh, you should never do power exercises. You should never do power exercises at the end of a workout, God forbid. One that to me is silly, and as well as Joe Ken from the Carolina Panthers thinks that's silly, because in a real life situation in competition, you need power at the end too when you're tired. So repeatability, endurance is a big part of power development as well. Probably not the most important part. You guys can see that. Obviously, you know, endurance isn't everything, but repeatability. My volleyball players, I'm okay if their vertical is only 25 inches or so if they can do a 23-inch jump 10 times in a row. Does that make sense? As opposed to, hey, my vertical's 27, but I'm really only I'm 25, 24, 23. It's inconsistent because I can't repeat the power movement. So a lot of times it's not about just one number, how high you can jump, it's the ability to repeat it. That make sense? That's about as much as I'm going to say there. How do you enhance it? Moderate to high volume, a lot of repetitions, short range of motion. You know, you can go full, but it's just repeatability into a power skill. We're kind of running out of time, or else I'd go through each one of those. You guys will get the slides. So one thing here, our staff loves this video because we do this workout. It's the Klokov Tabata. So he's got his video on, and he sets up an entire weight room of all this cleans and jerks, and he just runs around the room just doing it all. And this will destroy you if you attempted it, trust me, I promise you. It's so metabolically taxing, but you're doing a bunch of power movements over and over and over again. And we laugh because the weight that we use doesn't even come close to the weight that he's using. But over and over again, he's got great posture as he goes through this, great technique. He's flattening his back before he pulls. So to us, what does this look like? Starts with a C. CrossFit. This kind of looks like CrossFit, and automatically say, oh no, that's stupid. Why would you do that? You know, but there's really a lot to be said about training in a way that is metabolically taxing with power type movements. And that again, it comes down to repeatability and just training the metabolic systems to keep up with it. So Melrose did a good job of explaining how there's the ATP system, the glycolytic system, and there's duration of different things. Well, those systems are all trainable as well. But the one thing I'll say in this slide, because we're running out of time, power comes at a cost, okay? It costs something. It costs energy substrates. Can we train it to where it doesn't cost as much, or can we train it to where we're more efficient with producing it again? And that all comes down to metabolic processes within our body, within our muscles. Does that make sense to you guys? Efficiency, economics is a word that you could use. How trained am I to tackle the same rep over and over and over again without being too taxing? Falls under two categories: aerobic, anaerobic metabolism. It's very sport dependent which one you go for. But at the end of the day, it is still absolutely important to your power success. If you're a football player, if you're a basketball player, volleyball player, being tired is just not an option, right? You can't afford to be tired or gassed out, or you have to be able to drive through your entire length of competition, and you have to be able to do that efficiently. I mean, nobody can argue with that. So it absolutely has a big role in power production. So putting it all together, I have this little video of these Canadian rowers. These guys in this video are training 3 times a day, 6 days a week for as long as an hour and a half. And it's always together, it's always in unison, it's always synchronized. But to me, the example of a rower is just so perfect with our illustration because it has to do with velocity, force, range of motion, endurance. I mean, there's so many elements that we just went over that are involved here. Here you guys see these guys who are rowers who people might think are aerobic athletes. They're doing Olympic weightlifting. They're doing strength training. And I guarantee you their program for winning an Olympic medal incorporates all 8 of the things that we just talked about in a very perfect, prescribed, and balanced way to maximize their sport, okay? Rowing might use the 8 a whole lot differently than football might use the 8, right? There might be a certain emphasis on one area than there is the other. It's up to us, the people in this room, when you're creating a program, to know which area to really emphasize the most and at what time of the year and all that, okay? And unfortunately, that requires a lot more education on y'all's part, but hopefully that at least opens your mind to thinking, okay, here I got one sport that I got to work with. How can I maximize the 8 things there? Okay, questions? No, I kind of went a little long. Yes?
Talk about power duration, like 0.9 seconds, 10 seconds. What's the recovery time?
Yeah, that's definitely an area that I didn't really talk about as much. That is such a huge role with training is recovery time. There are some activities that we just went over, like with the 8, power, strength. Some activities require greater recovery time and some of them don't. My best source for finding out what recovery time is optimal is looking at the sport itself. So for volleyball, when I was training volleyball, I've been training volleyball for about 3 years now here, I went immediately to some data that showed the typical length of time between a rally, or I mean, between a set, and the typical length of time between the next play, or whatever you call it. And so based on those average statistical measures, there was about a 1 to 2.2 ratio of work to rest. And so a lot of the way I train is based on that alone. So, we train a little bit before and after that, but whether regardless of its strength or power, sometimes we work within those parameters and we train them accordingly. But it is important to understand that some of these explosive, heavy movements with 80% of your max on a clean and jerk probably going to require you to take a little bit longer of a break, as long as 2 minutes. I wish I had actually put that on there. But you guys, if you go to the NSCA website or some of their texts, it shows, hey, this exercise and how much recovery you should probably have in between based on just safety and just the ability to execute it again. Chances are, if you try to do it another time and it looks terrible and it sucks and something went wrong, you probably should have rested a little longer. Or maybe you're just mental discipline is your focus and you're okay with the technique going down the drain a little bit because you're just trying to build, just pushing through it, and then that could be a different context. So it's really relative, but that's a great question. Yes, we'll do one more.
You had mentioned one point in there that the simplified movements like the deadlift, the back squat, simple things like the hip hinge,